Welcome to the DIY Honda Garage channel. For the Honda Odyssey models from 2011 to 2017, the diagnostic trouble code B1225 indicates an open circuit in the in-car temperature sensor. This code is crucial because it affects the vehicle's climate control system, which is responsible for maintaining the comfort of drivers and passengers by regulating cabin temperature. The in-car temperature sensor plays a significant role in monitoring the internal climate conditions, ensuring that the air conditioning or heating operates as intended. Located generally near the vehicle's dashboard, this sensor collects the air temperature to adjust HVAC settings accordingly. When the circuit has an open, the climate control unit may not receive accurate temperature readings, resulting in malfunctioning systems. To address this issue, a series of systematic troubleshooting steps must be undertaken to identify the source of the problem and implement the necessary repairs. DTC B1225 specifically pertains to the failure of the in-car temperature sensor, which monitors the cabin air temperature to ensure the comfort of occupants within the Honda Odyssey. Its primary role is to relay temperature data to the climate control unit, allowing for appropriate adjustments to heating and cooling systems based on current conditions. The in-car temperature sensor is typically located on the dashboard or near the vents, positioned strategically to get an accurate reading of the air temperature inside the vehicle. If the sensor fails or becomes disconnected, the climate control system will not function correctly, causing potential discomfort for passengers. This could lead to overheating or undercooling, which is why addressing a DTC like B1225 is critical. Diagnosing the root cause of this malfunction involves examining the entire sensor circuit for issues such as broken wires, loose connections, or an outright sensor failure. Various factors may contribute to the triggering of DTC B1225, primarily focusing on the wiring and components associated with the in-car temperature sensor. One potential cause is an open circuit within the sensor's wiring, which prevents the climate control unit from receiving the necessary input. This could occur due to physical wear, abrasion, or even critter damage to the wires. Additionally, a malfunctioning temperature sensor itself could produce incorrect signals or no signal at all, leading to the DTC being stored. Furthermore, loose or corroded connections in the wiring harness can create intermittent faults, which may cause erratic behavior in climate control functions. It's critical to systematically evaluate each of these areas when troubleshooting B1225 to ensure a comprehensive diagnosis and repair process. Drivers and passengers may experience several symptoms indicating the presence of DTC B1225 in the Honda Odyssey. One of the most noticeable issues is inconsistent cabin temperature control, where the HVAC system fails to maintain the desired temperature set by the driver. This can manifest as the system blowing air that is either too hot or too cold. Additionally, the climate control unit may display warning indicators, such as the auto light, alerting the driver to a malfunction within the temperature sensing system. Poor performance during defrosting can also be observed, as the system relies on accurate temperature readings to effectively manage the glass defrosting functions. These symptoms should not be ignored, as they signify that further investigation is needed to address the underlying problems associated with the in-car temperature sensor circuit. The first troubleshooting step in addressing DTC B1225 involves clearing any existing diagnostic trouble codes using the Honda Diagnostic System, HDS. The HDS is a specialized tool designed to communicate with the vehicle's onboard diagnostics and accurately reset various systems. This step is crucial because it ensures that any transient errors are erased, establishing a baseline for diagnosing the current state of the climate control system. Resetting the system states can help eliminate false readings that may have occurred due to previous malfunctions. Ensure that the vehicle is in a safe state and the ignition is turned on as you utilize the HDS to clear the codes. After completing this step, it is essential to proceed with the next debugging steps to thoroughly evaluate the temperature sensor circuit. In the second step of troubleshooting, you'll need to turn the ignition switch to the lock position, then back to the on second position. This step serves to power up the vehicle's electronic systems, setting the stage for a careful self-diagnostic function of the in-car temperature sensor. The process of switching off and turning the ignition back on is often necessary to reset various components within the vehicle, preparing them for diagnostic testing. This action helps ensure that the climate control unit is operational and ready for evaluation. Once the ignition is in the on position, the system will be primed to conduct a self-diagnostic function, identifying any current or pending faults in the circuitry related to the temperature sensor. The third step involves executing a self-diagnostic function, which can be performed using the Honda Diagnostic System, HDS, or the vehicle's climate control unit itself. This self-assessment process checks the functionality of the in-car temperature sensor and the associated circuits to ensure everything operates as intended. After running the diagnostic, it is essential to verify if the DTC B1225 appears again. If it shows up, this indicates that the problem persists and requires further investigation. However, if the code does not appear, it may suggest an intermittent failure, possibly caused by loose connections or poor wiring. The self-diagnostic function is a pivotal step in identifying whether the system can rectify issues on its own, or if human intervention is required for more in-depth troubleshooting. At this stage, you will check once more to see if DTC B1225 is still indicated in the system after performing the self-diagnostic function. If the code is present, it indicates a persistent issue within the in-car temperature sensor circuit. This is a critical moment where you should conduct a thorough visual inspection of the wiring and connectors associated with the temperature sensor. Look for signs of wear, such as frayed wires, corrosion, or loose connections, all of which could contribute to the open circuit condition. If the DTC does not appear, it may suggest that the issue could be intermittent. It's important to regularly assess wiring conditions as they can deteriorate over time due to exposure to elements or mechanical wear, which might lead to malfunctioning components like the in-car temperature sensor. The fifth troubleshooting step requires turning the ignition switch back to the lock position before proceeding to remove the humidity and in-car temperature sensor. This precaution is vital to prevent any electrical shorts or further issues while handling the components. Once the ignition is off, carefully disconnect and remove the temperature sensor from its mounting location. It's important to handle the units with precision, as excessive force may cause damage to the sensor or surrounding components. Once removed, prepare for testing the in-car temperature sensor to confirm its functionality. This step is crucial, as any fault in the sensor itself could directly contribute to the generation of DTC B1225, and understanding its operational status is key for next steps. In the sixth step, you will test the removed in-car temperature sensor to evaluate its operational readiness. To get an accurate picture of the sensor's condition, check its resistance values against the specifications laid out in the service manual for your specific model year. A functioning sensor should return a certain resistance value at various temperatures. If values deviate from the expected range, this indicates that the sensor has indeed failed. If you confirm that the temperature sensor is working properly, It will lead you to the next step in the troubleshooting process. However, if the sensor fails the test, it is essential to replace it to restore proper function to the climate control system. The in-car temperature sensor is critical for regulating interior temperatures and ensuring passenger comfort, making it essential for the vehicular climate control system to operate effectively. In the 7th troubleshooting step, disconnect the climate control unit connector B, which features 16 pins. This step is necessary to evaluate the electrical connection between the climate control unit and the humidity in-car temperature sensor. After disconnecting, you need to check for continuity between terminal number 1 of connector B and terminal number 1 of the 4-pin connector connected to the humidity in-car temperature sensor. Continuity testing will determine whether there is an unbroken electrical path between these 2 points. If continuity is present, that suggests the wiring between the climate control unit and sensor is intact, leading you closer to potential issues elsewhere in the circuit. A lack of continuity indicates there is an open wire that must be repaired to restore proper functionality, allowing the climate control unit to receive accurate temperature readings again. Following the previous step, in the 8th troubleshooting process, disconnect the climate control unit connector A, which has 28 pins. You'll then check for continuity between terminal number 13 of this connector and terminal number 2 of the humidity in-car temperature sensor's 4-pin connector. Continuity at this point indicates that there are no breaks in the wiring beyond connector A, further ruling out issues in the connection from the climate control unit to the sensor. If continuity does exist, this confirms the circuit's integrity is intact up to this point. However, if you find there is no continuity, it's crucial to investigate for possible faults in the wiring that could be causing an open circuit condition. Checking for proper connections and ensuring there are no corrosion or pin damage is essential in this step to ensure stable communication between the components. After completing all necessary repairs, the final repair verification step is crucial for confirming the success of your work on DTC B1225. Begin by rechecking all connectors and wire connections to ensure they are properly secured and free from any corrosion or physical damage. After ensuring the connections are solid, perform a functional test on the climate control system to verify it is operating as intended. This should include checking the in-car temperature readings and ensuring that the HVAC system responds correctly to temperature adjustments. Lastly, utilize the Honda Diagnostics system to confirm that DTC B1225 is no longer present in the system. By carefully performing this final check, you can ensure that the repairs made were effective, allowing the vehicle's climate management systems to function properly once again. Preventive maintenance is vital to ensure the longevity of the in-car temperature sensor and its associated circuitry in the Honda Odyssey. Regular inspections of wiring should be part of routine vehicle maintenance, helping to identify potential issues before they escalate into larger problems. Corrosion, wear, or loose connectors can be spot-checked when performing other routine upkeep tasks, such as checking fluids or replacing filters. Additionally, being proactive about the performance of the humidity/in-car temperature sensor contributes to maintaining a fully functional climate control system. If there are signs of failure or irregular readings, addressing them promptly can significantly mitigate the risk of triggering DTC B1225 or similar codes. Consistent preventive actions keep the vehicle's HVAC system responsive, ensuring optimal comfort and functionality for all passengers. In conclusion, DTC B1225 indicates a significant issue with the in-car temperature sensor circuit in the Honda Odyssey models from 2011 to 2017. successful troubleshooting involves following a systematic approach to identify and rectify any wiring issues, sensor malfunctions, or connectivity failures. Understanding the roles of each component is essential to ensure effective resolution of any faults leading to DTC B1225. After performing the necessary diagnostics, repairs, and testing, it is crucial to validate that the climate control system operates as intended without recurring errors. Preventive maintenance measures should also be implemented to avoid future occurrences, ensuring the comfort and functionality of the vehicle's climate settings are preserved. In essence, maintaining a healthy in-car temperature sensor circuit is key to enjoying a pleasantly controlled cabin environment. Please like and subscribe to the channel. See you next time!